Hi everyone, welcome back again. Looking at special cases for logs. If I want to find the log of 2 with a base of 2, I want to find out what it is, I can put an X there. Then I have what I call the squish method. If you want to watch it on earlier videos, if I squish the 2 out, I get the X on top, and this becomes a 2 there. Let's check if these two statements are the same. The log of 2 is X with a base of 2. So there's our log form and there's our index form or exponent form, so that's correct. Now I can write that as 2 to the 1, and I can now equate the indices, and I've got X equals 1. So for me, I will look at it and say 2 to the what is 2, and 2 to the 1 is 2. Next one, can go the same process, the long way, call it X, squish the 3 out, and I've got 3 equals 3 to the X. Check the statement's correct. The log of 3 is that number up here with a base of 3. So the log of 3 base 3 is that number up here. So here we go. That's a 3 to the 1, so the answer is X to the 1. So we can write anything now. We can log of 10 base 10, and that's 1. We can log the log of 5 base 5, and that's 1. So the log of a number with the same base is going to be 1. Now the different one. This one marks people's brains up. If I come over to here, if you divide anything by itself, you get 1. And that's obvious. So if I wrote that as 5 squared, and I wrote that as 5 squared, I've got to still get 1. It has to be the same thing. By the index laws, all they created was 5 times 5 would be 5 squared, and 5 times 5 times 5 would be 5 cubed. And then as a result of it, we subtract the power when the bases are the same. So this will be 5 to the 2 take 2, which is 5 to the 0. So anything divided by itself gives you 1. If I apply the index laws to the same question, I get 5 to the 0. So we now know that 5 to the 0 is 1, which means that 2 to the 0 is 1, and 3 to the 0 is 1, anything to the 0 is 1. Let's go through this. This has to be 0, but let's call it X. If I write it now in index form, there's my 1. I squish the 5 out, and the X goes onto the top. Here's the problem. 5 to the what is 1. Now if someone knows those and knows those well, they can just write down the 0. So it's really coming back to how well do you know that law. This one over here equals X. So I have 1 equals 10 to the X, because I squashed the 10 out to the other side, the X goes on top. 10 to the what's 1, and I have X is 0. So I can go to the log of 1 with a base of 7, I can just say that's 0. I can go to the log of 1 with a base of 9 and go 0. So the log of anything, which is a 1, becomes a 0. Thanks. Please don't forget to like and subscribe.